A woman who is colorblind with both of her X chromosomes carrying the colorblind trait can expect 100% of her female offspring to be colorblind, 100% of her male offspring to be colorblind, 50% of her female offspring to be colorblind, or 50% of her male offspring to be colorblind. Traits that are carried on the X chromosome are called sex-linked traits. And males are far more likely to acquire a sex-linked trait than females. This is because males only have one X chromosome, and if that X chromosome contains this mutation, then they will have that trait. But females contain two X chromosomes, so they have to have the mutation on both chromosomes in order to have this trait. Just like the woman in this question, it's possible for a female to be colorblind. It just takes two X chromosomes instead of one, and so it's far less likely that you'll end up with a female who is colorblind. So let's do a Punnett square to see exactly what this woman should expect. And let's say that her husband doesn't have any mutation. He has a normal X chromosome and normal vision. Both of her X chromosomes carry the trait. And now let's look at the males and females. These two boxes represent males because they're XY, and these two boxes represent females. Notice that both of the males have the colorblind trait, meaning that 100% of the males are colorblind. But 0% of the females in this case are colorblind because they only have one X chromosome with the colorblind trait. Now, they are all carriers, meaning that they could have offspring later that has colorblindness, but none of them will be colorblind. They're carriers. They don't have the trait. So, whenever a woman has colorblindness, she can expect all of her sons to be colorblind, even if she marries a man with normal vision, because males get their X chromosome from their mother. And if she only has X chromosomes that carry the trait, then she will give one of those X chromosomes to her sons, and they will have the trait. That's why we call it a sex-linked trait. It's on the sex chromosome, and it affects males far more than it affects females.